Chapter 1. Rational Numbers. We have already learnt about natural numbers, whole numbers, integers, fractions and rational numbers in earlier classes. In this chapter, we will study the properties of rational numbers and various operations which can be performed on them. Rational numbers. The numbers which can be written in the form P upon Q, where P and Q are integers and Q not equal to 0 are called rational numbers. For example, 3 upon 5, minus 2 upon 7, 4 upon minus 11 and minus 5 upon minus 8 are rational numbers. Positive rational numbers. A rational number is said to be positive if its numerator and denominator are either both positive or both negative. For example, 7 upon 3, minus 3 upon minus 7, 2 upon 3, minus 4 upon minus 7 are positive rational numbers. Negative rational numbers. A rational number is said to be negative if either numerator or denominator is negative. For example, minus 5 upon 9, 3 upon minus 7, minus 4 upon 5, 2 upon minus 3 are negative rational numbers. Further, all integers 4, 5, minus 3, minus 7, etc. can be written in the form of rational number as 4 upon 1, 5 upon 1, minus 3 upon 1, minus 7 upon 1, etc. The number 0 can also be written as 0 upon 1, 0 upon 2, 0 upon 3, etc. Hence, all integers, whether positive, negative or 0, are rational numbers. Equivalent rational numbers. If P upon Q is a rational number and M is a non-zero integer, then P upon Q is equal to P into M upon Q into M. For example, minus 3 upon 5 is equal to minus 3 into 2 upon 5 into 2, which is equal to minus 3 into 3 upon 5 into 3, which is equal to minus 3 into 4 upon 5 into 4. This implies minus 3 upon 5 is equal to minus 6 upon 10, which is equal to minus 9 upon 15, which is equal to minus 12 upon 20. Standard form of a rational number. A rational number P upon Q is said to be in standard form if denominator Q is positive and P and Q have no common divisor other than 1. Example, express each of the following rational numbers in standard form. 1. 30 upon minus 72. Solution. 30 upon minus 72 is equal to minus 30 upon 70, which is equal to, within bracket, minus 30 divided by 6 upon, within bracket, 72 divided by 6, which is equal to minus 5 upon 12. Absolute value of a rational number. It is the numerical value of a rational number ignoring its sign. To find the absolute value of a rational number, we take absolute value of numerator and absolute value of denominator. If P upon Q is a rational number, then absolute value of P upon Q is written as P upon Q, which is equal to P upon Q. It is either 0 or greater than 0. Example, find the absolute value of the following rational numbers. 5 upon 12. Solution. 5 upon 12 is equal to 5 upon 12, which is equal to 5 upon 12. Representation of rational numbers on the number line. The integers minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3, 4, and so on can be represented on the number line as follows. The rational number 1 upon 2, which is halfway between 0 and 1, and number minus 1 upon 2, which is halfway between 0 and minus 1, can be shown on the number line as below. For representation of rational number 1 upon 3, we divide the distance between 0 and 1 into 3 equal parts, and for minus 1 upon 3, we divide the distance between 0 and minus 1. Towards left of 0 into 3 equal parts, and the rational numbers 1 upon 3 and minus 1 upon 3 can be marked on the number line as shown below. The rational number 2 upon 3 will be between 1 upon 3 and 1, whereas minus 2 upon 3 will be between minus 1 and minus 1 upon 3.
Example:
Represent rational number minus 4 upon 5 on the number line. Solution: to represent rational number minus 4 upon 5, we divide the distance between 0 and minus 1 into 5 equal parts. Starting from 0, move towards minus 1 left, and the fourth mark will represent minus 4 upon 5 as shown below. Comparison of rational numbers. Let us compare the rational numbers without using number line. We know that every positive rational number is greater than 0. For example, 3 upon 5 greater than 0. Every negative rational number is less than 0. For example, minus 5 upon 9 less than 0. Note, while comparing the rational numbers, a first step is to make denominator of rational number positive. Method of comparing rational numbers. Step 1. Express the rational number with positive denominators. Step 2. Take LCM of the positive denominators. Step 3. Express each rational number, as in Step 1, with LCM as common denominator. Step 4. Compare the numerators. The number having the greater numerator is greater.
Example:
Compare the following rational numbers: 3 upon 5 and 2 upon 3. Solution: the two rational numbers are 3 upon 5 and 2 upon 3. The LCM of denominators 5 and 3 is 15. We make denominator of each rational number equal to 15. 3 upon 5 is equal to 3 upon 5 into 3 upon 3, which is equal to 9 upon 15. 2 upon 3 is equal to 2 upon 3 into 5 upon 5, which is equal to 10 upon 15. On comparing 9 upon 15 and 10 upon 15, we find that the numerator 9 less than 10. Therefore, 9 upon 15 less than 10 upon 15. This implies 3 upon 5 less than 2 upon 3. Alternative method of comparing rational numbers. We can also compare the rational numbers by using cross-multiplication method.
Example:
Compare the following: minus 5 upon 8, minus 3 upon 7. Solution: the two rational numbers are minus 5 upon 8 and minus 3 upon 7. Using cross-multiplication, minus 5 into 7, minus 3 into 8, minus 35, minus 24. Since minus 35 less than minus 24, therefore, minus 5 upon 8 less than minus 3
Addition
upon
of
7. Rational numbers. The addition of rational numbers is carried out in the same way as that of the addition of fractions. Before adding rational numbers, their denominator is made positive. Adding rational numbers with same denominator. Let the two rational numbers be a upon c and b upon c, having common denominator c. On adding both the rational numbers, we get a upon c plus b upon c, which is equal to a plus b upon c. To add the rational numbers having same denominator, we follow the following steps. Step 1. Add the numerator. Step 2. Write a rational number whose numerator is the sum obtained in Step 1 and whose denominator is the common denominator of the given rational numbers.
Example:
Find the sum of the following rational numbers: 6 upon 11 plus minus 15 upon 11. Solution: 6 upon 11 plus minus 15 upon 11 is equal to 6 plus minus 15 upon 11 is equal to minus 9 upon 11. Adding rational numbers when denominators of the given numbers are unequal, we follow the following steps. Step 1. If the denominator of the given rational number is negative, rewrite it so that the denominator becomes positive. Step 2. Find the LCM of denominators. Step 3. Express each number with the LCM as common denominator. Step 4. Write a rational number whose numerator is the sum of the numerators and denominator is the LCM obtained in step 3.
Example,
Find the sum of the following rational numbers: 6 upon 13 and minus 4 upon 39.
Solution 1. The LCM of denominators 13 and 39 is 39. 6 divided by 13 is equal to 6 divided by 13 multiplied by 3 divided by 3 is equal to 18 divided by 39. Minus 4 divided by 39 multiplied by 1 divided by 1 is equal to minus 4 divided by 39.
6 upon 13 plus minus 4 upon 39 is equal to 18 upon 39 minus 4 upon 39, which is equal to 18 minus 4 upon 39, which is equal to 14 upon 39. Properties of addition of rational numbers. Closure property. If A upon B and C upon D are two rational numbers, then A upon B plus C upon D is also a rational number. Examples. Consider the rational numbers 1 upon 3 and 4 upon 9. Then
1 divided by 3 plus 4 divided by 9 is equal to bracket 1 divided by 3 multiplied by 3 divided by 3 plus bracket 4 divided by 9 multiplied by 1 divided by 1 is equal to 3 divided by 9 plus 4 divided by 9 is equal to 3 plus 4 divided by 9 is equal to 7 divided by 9, which is a rational number.
consider the rational numbers 3 upon 4 and minus 5 upon 8. Then 3 upon 4 plus minus 5 upon 8 is equal to 3 upon 4 into 2 upon 2 plus minus 5 upon 8 into 1 upon 1, which is equal to 6 upon 8 plus minus 5 upon 8, which is equal to 6 minus 5 upon 8, which is equal to 1 upon 8, which is a rational number. Commutative property. Two rational numbers can be added in any order. If A upon B and C upon D are two rational numbers, then A upon B plus C upon D is equal to C upon D plus A upon B. Examples. Consider the rational numbers 3 upon 4 and 5 upon 6. Then 3 upon 4 plus 5 upon 6 is equal to 3 into 3 upon 4 into 3 plus 5 into 2 upon 6 into 2, which is equal to 9 upon 12 plus 10 upon 12, which is equal to 9 plus 10 upon 12, which is equal to 19 upon 12. Also, 5 upon 6 plus 3 upon 4 is equal to 5 into 2 upon 6 into 2 plus 3 into 3 upon 4 into 3, which is equal to 10 upon 12 plus 9 upon 12, which is equal to 19 upon 12. Hence, 3 upon 4 plus 5 upon 6 is equal to 5 upon 6 plus 3 upon 4. Associative property. While adding three rational numbers, they can be grouped in any order. If A upon B, C upon D, E upon F are three rational numbers, then in brackets, A upon B plus C upon D plus E upon F is equal to A upon B plus, within brackets, C upon D plus E upon F. Example. Consider the rational numbers minus 3 upon 4, 5 upon 6 and 2 upon 9. Then minus 3 upon 4 plus 5 upon 6 plus 2 upon 9 is equal to, within brackets, minus 9 upon 12 plus 10 upon 12 plus 2 upon 9, which is equal to 1 upon 12 plus 2 upon 9, which is equal to 3 upon 36 plus 8 upon 36, which is equal to 11 upon 36. Also, minus 3 upon 4 plus within brackets 5 upon 6 plus 2 upon 9 is equal to minus 3 upon 4 plus within brackets 15 upon 18 plus 4 upon 18, which is equal to minus 3 upon 4 plus 19 upon 18, which is equal to minus 27 upon 36 plus 38 upon 36, which is equal to 11 upon 36. Existence of additive identity. If A upon B is a rational number, then there exists a rational number 0, such that A upon B plus 0 is equal to 0 plus A upon B, which is equal to A upon B. The number 0 is called the additive identity for rational numbers. Examples: 3 upon 7 plus 0 is equal to 0 plus 3 upon 7, which is equal to 3 upon 7.
2. Minus 4 divided by 5 plus 0 is equal to 0 plus bracket minus 4 divided by 5 is equal to minus 4 divided by 5.
Existence of additive inverse. If A upon B is a rational number, then there exists a rational number minus A upon B, such that A upon B plus minus A upon B is equal to 0. Similarly, minus A upon B plus A upon B is equal to 0. A upon B and minus A upon B are called additive inverse of each other. Example: consider the rational numbers 3 upon 7 and minus 3 upon 7. Then 3 upon 7 plus minus 3 upon 7 is equal to minus 3 upon 7 plus 3 upon 7, which is equal to 0. Thus, 3 upon 7 and minus 3 upon 7 are additive inverse of each other. Subtraction of rational numbers. The difference of two rational numbers, A upon B and C upon D, is defined as A upon B minus C upon D, which is equal to AD minus BC upon BD. Example: subtract 6 upon 7 from 4 upon 5. Solution: 4 upon 5 minus 6 upon 7 is equal to 28 minus 30 upon 35, which is equal to minus 2 upon 35. Properties of subtraction of rational numbers. Closure property. If A upon B and C upon D are two rational numbers, then A upon B minus C upon D is a rational number. That is, difference of two rational numbers is a rational number. Examples: consider the two rational numbers 7 upon 3 and 3 upon 4. Then 7 upon 3 minus 3 upon 4 is equal to 28 minus 9 upon 12, which is equal to 19 upon 12, which is a rational number. Commutative property. If A upon B and C upon D are two rational numbers, then A upon B minus C upon D not equal to C upon D minus A upon B. That is, subtraction of rational numbers is not commutative. Example: if 3 upon 4 and 7 upon 8 are two rational numbers, then 3 upon 4 minus 7 upon 8 is equal to, within brackets, 3 into 2 upon 4 into 2, minus 7 upon 8, which is equal to 6 upon 8 minus 7 upon 8, which is equal to 6 minus 7 upon 8, which is equal to minus 1 upon 8. Also, 7 upon 8 minus 3 upon 4 is equal to 7 upon 8 minus, within brackets, 3 into 2 upon 4 into 2, which is equal to 7 upon 8 minus 6 upon 8, which is equal to 7 minus 6 upon 8, which is equal to 1 upon 8. Hence, 3 upon 4 minus 7 upon 8 not equal to 7 upon 8 minus 3 upon 4. The other properties of rational numbers, like associative property, identity property, and inverse property, do not hold good under subtraction. Let us take some more examples of addition and subtraction of rational numbers. Example 1. What should be added to minus 7 upon 8 to get minus 3 upon 2? Solution. Let the number to be added be x. Then minus 7 upon 8 plus x is equal to minus 3 upon 2. This implies x is equal to 7 upon 8 minus 3 upon 2, which is equal to 7 minus 12 upon 8, which is equal to minus 5 upon 8. Hence, minus 5 upon 8 multiplication of rational numbers. If a upon b and c upon d are any two rational numbers, then a upon b into c upon d is equal to a into c upon b into d. That is, the product of two rational numbers is equal to product of their numerators upon product of their denominators.
Example:
Multiply 3 upon 4 by 3 upon 7. Solution: 3 upon 4 into 3 upon 7 is equal to 3 into 3 upon 4 into 7, which is equal to 9 upon 28. Properties of multiplication of rational numbers. Closure property. The product of two rational numbers is always a rational number. If a upon b and c upon d are two rational numbers, then a upon b into c upon d is also a rational number.
Example:
Consider two rational numbers, 2 upon 3 and 5 upon 7. Then their product, 2 upon 3 into 5 upon 7 is equal to 10 upon 21, which is a rational number. Commutative property. Two rational numbers can be multiplied in any order. Thus, if a upon b and c upon d are two rational numbers, then a upon b into c upon d is equal to c upon d into a upon b.
Example:
Let two rational numbers be 7 upon 8 and 2 upon 3. Then 7 upon 8 into 2 upon 3 is equal to 7 into 2 upon 8 into 3, which is equal to 14 upon 24, which is equal to 7 upon 12. Also, 2 upon 3 into 7 upon 8 is equal to 2 into 7 upon 3 into 8, which is equal to 14 upon 24, which is equal to 7 upon 12. Hence, 7 upon 8 into 2 upon 3 is equal to 2 upon 3 into 7 upon 8. Associative property. While multiplying three or more rational numbers, they can be grouped in any order. For any three rational numbers, a upon b, c upon d, e upon f, a upon b into c upon d into e upon f is equal to a upon b into c upon d into e upon f. Let us consider three rational numbers be 1 upon 2, minus 3 upon 7 and minus 5 upon 2. Then 1 upon 2 into minus 3 upon 7 into minus 5 upon 2 is equal to minus 3 upon 14 into minus 5 upon 2, which is equal to minus 3 into minus 5 upon 14 into 2, which is equal to 15 upon 28. Also, 1 upon 2 into minus 3 upon 7 into minus 5 upon 2 is equal to minus 1 upon 2 into minus 3 into minus 5 upon 7 into 2, which is equal to 1 upon 2 into 15 upon 14, which is equal to 15 upon 28. Hence, 1 upon 2 into minus 3 upon 7 into minus 5 upon 2 is equal to 1 upon 2 into minus 3 upon 7 into minus 5 upon 2. Existence of multiplicative identity. For any rational number a upon b into 1 is equal to 1 into a upon b, which is equal to a upon b. The number 1 is called the multiplicative identity for rational numbers. Example: minus 3 upon 11 into 1 is equal to 1 into minus 3 upon 11, which is equal to minus 3 upon 11. Existence of multiplicative inverse. If a upon b is a rational number, then there exists a rational number b upon a such that a upon b into b upon a is equal to 1. A upon b and b upon a are called multiplicative inverse or reciprocal of each other. Examples: the multiplicative inverse of 6 upon 7 is 7 upon 6. Since 6 upon 7 into 7 upon 6 is equal to 7 upon 6 into 6 upon 7, which is equal to 1. Multiplicative property of 0. Every rational number when multiplied by 0 gives 0. For every rational number, a upon b into 0 is equal to 0 into a upon b, which is equal to 0. Example, 5 upon 13 into 0 is equal to 0 into 5 upon 13, which is equal to 0. Minus 3 upon 11 into 0 is equal to 0 into minus 3 upon 11, which is equal to 0. Distributive property. For any three rational numbers, a upon b, c upon d, e upon f, we have a upon b into c upon d plus e upon f, which is equal to a upon b into c upon d plus a upon b into e upon f. Example, consider three rational numbers 2 upon 3, 4 upon 5 and 5 upon 7. Then 2 upon 3 into 4 upon 5 plus 5 upon 7 is equal to 2 upon 3 into 28 plus 25 upon 35, which is equal to 2 upon 3 into 53 upon 35, which is equal to 106 upon 105. Also, 2 upon 3 into 4 upon 5 plus 2 upon 3 into 5 upon 7 is equal to 8 upon 15 plus 10 upon 21, which is equal to 56 plus 50 upon 105, which is equal to 106 upon 105. Hence, 2 upon 3 into 4 upon 5 plus 5 upon 7 is equal to 2 upon 3 into 4 upon 5 plus 2 upon 3 into 5 upon 7. Word problems. Example 1. Write the reciprocal of each of the following rational numbers. 9 minus 13. Solution. 1. The reciprocal of 9 is 1 upon 9. 2. The reciprocal of minus 13 is minus 1 upon 13. Division of rational numbers. The division is the inverse of multiplication and is defined below. If a upon b and c upon d are two rational numbers such that c upon d not equal to 0, then a upon b divided by c upon d is equal to a upon b into d upon c. Dividend. The number to be divided is called dividend. For example, a upon b is the dividend. Divisor. The number which divides the dividend is called divisor. For example, c upon d is the divisor. Quotient. When dividend is divided by the divisor, the result obtained is called quotient. For example, a upon b into d upon c is the quotient. Properties of division. Closure property. If a upon b and c upon d are two rational numbers where c upon d not equal to 0, then a upon b divided by c upon d is also a rational number. Example, consider two rational numbers 2 upon 3 and 5 upon 7. Then 2 upon 3 divided by 5 upon 7 is equal to 2 upon 3 into 7 upon 5, which is equal to 14 upon 15, which is a rational number. Division by number 1. For every rational number AB divided by 1 is equal to AB. For example, 3 upon 4 divided by 1 is equal to 3 upon 4 into 1 upon 1, which is equal to 3 upon 4. Similarly, A upon B divided by minus 1 is equal to minus A upon B. Example, find the value of the following. 3 upon 7 divided by minus 5 upon 4. Solution, 3 upon 7 divided by minus 5 upon 4 is equal to 3 upon 7 into minus 4 upon 5, which is equal to minus 12 upon 36. Rational numbers between two rational numbers. Let us find rational numbers between two given rational numbers. Can we guess how many rational numbers will be there between 3 upon 8 and 7 upon 8? At a glance, we may say that the rational numbers are 4 upon 8, 5 upon 8 and 6 upon 8. But besides these, there are many more rational numbers between them. There are rational numbers between 3 upon 8 and 4 upon 8, between 4 upon 8 and 5 upon 8, between 5 upon 8 and 6 upon 8, and also between 6 upon 8 and 7 upon 8. We may write 3 upon 8 and 7 upon 8 as 30 upon 80 and 70 upon 80 respectively. Now the numbers 31 upon 80, 32 upon 80, 33 upon 80, 34 upon 80, and so on, up to 69 upon 80, are all between 30 upon 80 and 70 upon 80. The same numbers may be written as 300 upon 800 and 700 upon 800. Then the numbers 301 upon 800, 302 upon 800, and so on, up to 699 upon 800 will be between 300 upon 800 and 700 upon 800. So, unlike natural numbers and integers, there are infinite rational numbers between two rational numbers. We can also use the idea of mean to find rational numbers between two given rational numbers. If a and b are two rational numbers such that a less than b, then a less than a plus b upon 2 less than b.
Example:
Find three rational numbers between -6 and -5. Solution: the rational number between -6 and -5 is equal to -6 minus 5 upon 2, which is equal to -11 upon 2. The rational number between -6 and -11 upon 2 is equal to, within brackets, -6 minus 11 upon 2 into 1 upon 2, which is equal to -23 upon 4. The rational number between -23 upon 4 and -5 is equal to, within brackets, -23 upon 4 minus 5 upon 1 into 1 upon 2, which is equal to -43 upon 8.